We command it using L-band and UHF going down, which is 400 megahertz.
It's like a secret space company in upstate New York.
Hey guys, today we're headed up to Cornell University for my 10-year class reunion. I'm really excited to connect with my old classmates and hear more about their Mechie journeys over the last 10 years. So stay tuned.
Hey buddy. Good morning. Are we going to CTB? Introduce yourself, Jesse. Who are you?
What? Oh, God.
Hey buddy.
You're a shameless son of a gun.
All right, here we go. Thanks, buddy.
What do you do when you don't know anything?
I hit up you guys and asked you guys to bail me out.
You don't go to Google, you don't be like, what is aerospace?
I do, but you guys are better at explaining it. Why don't you tell us a little bit about yourself?
So I'm Anjit. I am a program manager. I manage the mission extension vehicle for Northrop Grumman, and I also manage advanced concepts, which includes R&D efforts focused on life extension and servicing of other satellites on orbit.
So you've been with Orbital, which got bought by Northrop for a long time now. Can you tell us about your career journey and how you rose through the ranks?
I got in right at the beginning of this program, the spacecraft, where they were still just designing the mission extension vehicle. And then I saw that spacecraft through the 5 years of its design and launch and operation cycle. So we actually went through and did the first ever commercial docking in space. And I was a systems engineer flying as a Sys-2, so just support engineer flying the spacecraft at the time in 2020. And then became Sys-1 for some operations in 2021 for MEV-2, because we launched 2 of these guys. We just undocked with our first customer that we docked with 5 years ago. So that kind of shows the reusability and the applicability of this technology in space. It really drives the fact that you can extend the life of satellites and assets in space that are millions and millions of dollars instead of just sending up a replacement one.
What does that timeline look like?
For a spacecraft right now, maybe old hat Aerospace is like 2 years to 4 or 5 years for general spacecraft. A lot of startups are coming out with their own smaller spacecraft that are, I'd say, not as complicated as the bigger guys, just because you have fewer parts, fewer things to interact with, shorter timelines there, and you can also use off-the-shelf parts. So maybe like 6 months to a year, depending on what you're working on.
What does entrepreneurship in the space industry look like? What kind of companies can people interested in space or satellites get funded and develop?
So I think this has shifted over the years. It depends on the administrations. You have the groups who are running after government funding, the NASA missions to get to the moon, government DoD spending. Part of it is not inherently profitable to humanity down on Earth. Part of it is and has the potential to become profitable. You have like telecom satellites, DirecTV, SiriusXM radio, they all transmit and broadcast TV, internet, radio to Earth. And like GPS is another example of something that we actually use here on Earth. I think that there's a whole industry of low Earth orbit manufacturing that is starting to come about. As you have more and more of these assets out there in space, you need to find a way to service them. So I also think that the logistics and servicing industry is pretty key to this all as well. Focusing on how you can bring value back to Earth is the core value product for a lot of space, at least in the short term.
What do the economics or finances of this kind of space entrepreneurship look like?
The small sat kind of boom that happened a few years ago, where people started developing these smaller, very tiny satellites that are a tenth of the cost of the larger ones. The proliferation of that kind of class of satellites and the increased availability of components that you could buy off the shelf let you focus on like, okay, I don't actually have to rebuild every single part of the spacecraft myself. I can choose what I want to build in-house ourselves to try to make better, try to get something cheaper, putting different parts together for more low Earth orbit focused missions, which are generally lower time frame. And then obviously SpaceX's the Falcon 9 rockets have decreased the cost to get to orbit because they have a rideshare program where you can launch a lot of smaller satellites all at once, or maybe a combination of smaller satellites and then a really large satellite It used to be like hundreds of millions of dollars to launch satellites, and now it's more of the tens of millions. It also depends on what you're trying to launch, how big it is, and what orbit you're trying to reach, because that all affects cost.
Thanks so much for your time, buddy. Thank you.
Do you know what I do now?
Yes.
No, you don't know what I do. What do I do?
So hot. Hi, what's up? This is Leon Ex Machina coming to you live from Cornell.
Oh God, amazing. Why is this is so fun? Alright, thank you, Max. Happy to help. Wrap it before you tap it. Yeah, I'm sorry. All right. So hi, my name is Max Sandberg. I'm an aerospace engineer by training and by career. I've been working in the aerospace industry since I graduated. When I left college, I started working for SpaceX. I worked there for about 5 years. And now I work for a small aerospace parts manufacturer in central Pennsylvania.
Are you able to come on the record and say anything about your time at SpaceX?
Absolutely not. Thank you, though.
Oh, well, I guess that's a wrap.
So I'm an aerospace thermal engineer, which is a very niche field in a niche field. I do simulations specifically looking at the thermal aspect. So how hot are things going to get based on the heat loads applied and the environmental conditions. You have space, which is very cold. You have the sun, which is very hot, and usually one of those wins. Also, computers generate heat. Anything worth doing generates heat, and then you got to get rid of that heat off to the cold of space. Once I figured out how hot or how cold everything is going to get, then I get to work with the design engineers to fix it. Usually it's going to get too hot or too cold on the first cut. That's just how it happens. And no, it's nobody's fault. That's just how it works. When you're doing thermal simulations for like a computer or like a graphics card or something, you've got room temperature. Right, it's in a room. There's maybe a fan on it, it's blowing air, and air. There's none of that in space, unfortunately. So you can't really use that. So having to cool everything via like infrared radiation is a wholly different take on it. It's a niche field that I sort of spec'd into as an intern during undergrad, and I turned out to be really kind of good at it, and I like it, and so I've just kept doing it because it's fun. I was building a model of this cooling system for a spacecraft. On Thursday and Friday, and I was just like, oh man, I am so proud of this thing. I really love this model, and I put together a presentation for a customer yesterday, and they loved it. I had such a good time. I love my job.
Space has been like this black box for me, even though like one of my best friends, Anjit, has been doing satellites his whole life.
Yeah.
Because he actually gives me so much crap for like not having any idea what he does. And it's not that I don't care.
I don't think he cares.
Look at how G behind it. I gotta go eat with my fiance, or she's gonna kill me.
Yeah.
So Anjit will take over from here. Is gonna be Anjit Ex Machina. Anjit's a way better interviewer and just like person than me. So we're gonna have two space experts talking to each other, and I'm gonna buzz off.
Eat.
For
All
a
right.
bit. Yeah.
Enjoy.
All right. Enjoy.
Have fun.
What do we have to talk about?
You know what? When he said, "I want to interview you,"
Yeah.
given the pronouns in that sentence, I sort of thought that he
Was going
would
to
be interviewing
interview.
me, as opposed
I
to
know.
being not present for this at all.
I know.
So,
Maybe he won't even look at it. Maybe he won't even pay attention. We've been providing all the feedback, all of the information, and yeah, he's done nothing for this channel. I'm hacking this channel now. Come on. One sec.
Leon's got to get good, or he's going to get, he's going to be cooed.
He's not good at asking questions, but I feel like he's good at talking.
He is really good at talking. Rotate your body and turn more.
Like this?
And action.
The spacecraft breaks if it gets too hot, and the spacecraft breaks if it gets too cold. Like solder melts at like not that high of a temperature. And like, you ever take your phone and like live in a really cold environment, and you take it outside when it's like minus 20 degrees outside, and you can watch the battery go down because batteries don't like being cold, and then they explode when they get too hot. Moving the heat around effectively is really important, and it's harder in space than on Earth. And it's good that there are specialists for it, and there's the job security again. With my current job, I do a lot of consulting. I'm farmed out to a number of different space companies, maybe ones that are too small to have their own dedicated thermal engineer yet. Maybe they'll get one as they grow. But for right now, they need like a third of one. And so I can be a third of a thermal engineer for 3 different companies. That's efficiency. What's nice here is that a lot of the companies that I'm working for are are small speculative startups.
Yeah.
And I'll be honest, I'm a little risk averse.
Okay.
I love drawing like a normal engineering
Yeah.
salary and having a stable job. And I don't know if I want to work for a startup, but I would love to like get some exposure to the cool things that aerospace startups are doing these days. And so this is a nice happy medium. I still get the stability while also getting like interesting things to work on. Sometimes I'm designing a heat pipe for people. They need to move the heat from here to here, and they need a heat pipe that's shaped like that, and it needs to carry this much heat. Done. Easy.
Easy.
But on another company, I'm working on designing a pump fluid loop. How much fluid do we need to move to get to these radiators all over the spacecraft, to move all of this heat, and how hot is everything going to get when we do that, and how much colder will it get if we flow more liquid? I'm doing both of these at the same time, so I get to do a little like play around with little Cubesate heat pipes, and also play around with a big satellite's pump fluid loop.
That's cool.
I don't know, and I get to do some speculative stuff too. My company loves R&D, so I get to work with PhDs in thermofluid physics and weird boiling phenomena.
So you got a ton more experience than just working at one company.
Honestly, yeah. My time working at SpaceX did make me a very good thermal engineer. I became a very good jockey of this particular software package that's pretty standard across the industry. It's called Thermal Desktop. It's owned by ANSYS now. Other tricks you can use, I currently work a lot with heat pipes, which you probably have some of in your phone and your laptop and your gaming PC.
Oh, really? In my phone?
These days, actually, they've started using like really flat heat pipes.
What do they put in the heat pipe?
I think for those ones, water. It can't be anything toxic, right? It's going to go in consumer electronics, man.
If it breaks,
I put ammonia in my heat pipes for space, and you do not want to be anywhere near that stuff. Oh,
toxic.
Toxic as hell. What? Oh, sorry. What's a heat pipe? Oh my God. All right, it's a sealed tube. It's a tube with a little like liquid in it.
Yeah.
And the liquid's actually held right between the liquid and the vapor phases. So at the drop of a hat, it's gonna evaporate or condense. So if you have any hot spot on this metal tube, it's gonna cause some liquid to evaporate, and that carries some heat with it. And then if you have any cold spot on the tube, the vapor is going to condense back into liquid and drop the heat off. So heat moves really, really mass efficiently from the hot side to the cold side. It's a cool trick. They invented it for nuclear reactors back in the 60s, and it works really great for space as well. I consider a heat pipe still a passive technology because you don't have to like add power to it. It just kind of does this heat moving thing all on its own.
Reinforce the pipes too?
This is too technical.
Too technical.
We don't understand what's going
Okay.
Oh, we're having a great time though.
on. But I wouldn't be able to follow.
Okay.
Okay.
Leon, you got to shut this shit down. I thought you were the YouTuber here.
Yeah.
Stage mom is great, but I mean, you're the
I'm already
talent here.
reeling about how to like make this watchable. I take this.
Absolutely unwatchable.
Anything else you want to know?
I think that's a wrap.
Cool.
That's a wrap.
Done.
Yeah.
All right, thanks so much.
Yeah.
Test.
Yeah, you're good. Shut up. What are you doing, buddy?
Whoa. That's cool. That's a great shot.
You always talk about you were world champion at some point. You spend so much time here that you tanked your
so
GPA.
much time. I tanked my GPA.
Where?
Can we go into?
Oh, here.
Check out all the cool mechanical engineering project teams that you can join as a Cornell student. CUAV.
Just stop speaking.
Okay.
Oh my God, teaching assistant.
It's in yellow.
I'm legit.
This is the wall of fame. Plate with markers.
So tell me, Anjit, actually I'm curious. When did you get excited? When did you know that you wanted to do space engineering?
Oh, this is a double interview. I love this.
Double interview. Okay.
Then it's more like a conversation.
Yeah.
It's like a secret space company in upstate New York.
Entra un poco más. A little bit more. Más, más hacia este lado. Well, now you're too far. That's fine.
Is this a modeling shot?
Yeah, you're good.
Ramon, I'm originally from Spain. My career across the space industry has landed me into upstate New York. First couple of things being launched in a couple of weeks.
Why space?
I used to like things that go very fast and look cool. I wanted to come up with some crazy propulsion system that get people connected across the world in an hour rather than many hours right now. Eventually, through doing aerospace engineering, I found out the aeronautics industry was a little bit too mature for my liking. It was not so easy to implement new ideas and new concepts. On the other hand, in my last year of my bachelor's, I got involved with a space project dealing with bringing humans to Mars for the first time, participating in a competition. I didn't like any of the space courses during my bachelor. I thought satellites were the most unsexy thing in the world.
Really? Oh man.
They look awful. They're like a square box. They don't look. They don't look aerodynamic. It's like who designed these things to be so ugly? But yeah, eventually I realized that they are traveling a lot faster than airplanes, and that got me a little bit excited. And the next thing that got me really excited and got me hooked is just coming up with ideas for space missions, space technology that seemed to be better than what we were using, and looking on Google and actually not being disappointed that 100 other people had the same idea already. So yeah, it seemed like an industry where you could make a difference. You could come up with new concepts still. I guess I like the creative part of engineering, and choosing between aircraft and space. Space seemed a lot more fun to get into a career. Thales was expanding into the UK, so I arrived when we were only tens of people. I was there until it grew to a couple hundred people. Eventually, I felt like I wanted to be part of smaller teams, like my voice and what I did have a larger influence on the outcome of whatever project I was working on. So that's what led me to joining a smaller company, which is ABS. Before in my career, I was driven by working on the largest program that I could, so big constellations, big telecom satellites, because working on a several billion-dollar project that felt good. And career-wise, I guess that's what you could see as a good thing to grow in a big company.
Yeah.
But the mission of ABS and their founders is actually boosting scientific knowledge. Yeah, I found it to be a super rewarding work.
What are the most exciting niches in space right now?
Yeah, if we started a startup, what would we do it in? What would we make?
I'm very keen to get more humans living in space and working in space. A lot of the complexity of space is designing products and systems to work in an environment that most humans have not been in, and it's very challenging to imagine how things actually work there, and we have a ton of simulation software. I feel like a lot of the lack of agility and expensiveness of a space is the fact that we're designing things for an unknown environment. When humans are living in a space and they have to design things that they actually have a need for, just by the pure complexity of the environment and a survivability impulse, like they come up with the next big front of innovation. We could do great stuff for like space travel once we have actually communities in space thinking for space, living in space and trying to survive in space. Yeah. If you look at the Apollo era, it's like what was the space race? The biggest powers were competing. What was the biggest bragging right? Like getting to space and getting the first moon landing, and the amount of discoveries and new technologies, materials that you need to create when you set yourself a really hard challenge. You don't necessarily need to be solving for a solution that you know already.
All right, thanks so much.
Cool.
Thank you.
All right, thanks, Ramon.
Yeah.
I don't think you could go to your parents and be like, I'm a YouTuber now.
Capital L or U? Capital L. Oh, sorry, U. Okay. 3, 2, 1. Oh my goodness. This is a CubeSat. This is what's called a 1U or 1 unit CubeSat. CubeSats come in units of 10 by 10 by 10 centimeters. So you can have a 1U, you can stack one on top, get a 2U. That's what this thing is back here. What you usually see from a university group is a 1U CubeSat. Ours is a little special. Usually you buy this off the shelf or you design it yourself. We've designed the whole kit from scratch to be an open source, easy to use kit for universities. Let's see if I can pull this out. Everything is a card cage. Everything's hot swappable. So when this catches fire because your undergraduate students don't know how to solder lithium-ion batteries, then you just swap it out and you put in a new one, and it's great. Yeah. On the inside is backplane. We don't like wires, so these are the connectors for power and communications. We use something called the CAN bus, Controller Area Network, to talk amongst the cards. And then all of our RF stuff is on the backplane as well. This 1U has everything you would need on a CubeSat. Solar panel for generating power, a battery pack for storing the energy when you're behind the limb of the Earth. This is just a camera. We use it as a star tracker to see which way we're pointed. And then onboard computer to run the thing, run the radios, and then antennas. What's really important in CubeSats is that you actually have to keep everything stowed before you get deployed. So this is that same antenna array, just all curled up inside the little doors. We melt the little fishing wire and these guys spring out, and now we have a tri-band turnstile antenna. And all of this is open source. It's being used. Oh, thank you. Okay, that's where it went. That's all being used by other people, which is great, and we hope to get their feedback on how it works for them.
That's very cool. How do you get these guys into orbit?
You either have a really strong throwing arm, or you go to a rocket company. We make our own rockets, but no university group will ever put anything into orbit. It's too hard and it's too expensive. There's university groups that have gone to the edge of space, but not the actual orbital insertion. So we go to people who have orbital class rockets and give our stuff to them. The first CubeSat went to space on an Astra launch vehicle. This guy went to space on a SpaceX Transporter 11 through a company called ExoLaunch. And ExoLaunch basically makes the big boxes that you put your CubeSats in, close the door, go to space, and then you open the door and your CubeSat pops out. And that's very important because one of the best parts about CubeSats is that you don't have to go to the same quality standards, if you will, of the big satellites, right? They know that you're a university group or you've got risks, you've got weird things going on, everything was built by undergraduates. So we put our satellite in these deployer boxes to keep everybody else's satellite safe. That really reduces risk, which means that we can get away, not quite with murder, but bodily harm. We still have to test, but not to the same standards that a big satellite would have to test. So this is a 2U CubeSat. This is what we have in space right now. It's got a shortwave infrared camera. It's got a S-band or 2.4 gigahertz antenna that we can talk to. We command it using L-band and UHF going down, which is 400 megahertz. This satellite we can ostensibly control. We have these things, which are called magnetorquers. Those are actually just magnets, electromagnets. And when we turn them on, they produce a magnetic field that torques against the Earth's magnetic field. For a much faster pointing, we have a reaction wheel. And basically it's just a drone motor that we've turned into higher rotational inertia wheel.
How long do these guys stay in space and what can they do while up in orbit?
Our third mission that we're building right now will take this guy and actually fly it for the mission. So now we're going to look at cirrus clouds, the global distribution of cirrus clouds using this tri-band shortwave infrared camera. And then we're going to do a STEM outreach mission where we're beaming live video from space to Oregon high schools.
So cool. Thanks so much.
Yeah, absolutely.